Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 1 for October-November 2018, and the code is 9709/62. So let's move on to question number 1. For question number 1, first part, how many different arrangements are there of the letters in the word? Okay, so there are 11 letters here. So from these 11 letters, there are some repeating letters. So I will rewrite all these letters first. Then from here, I found that there are a total of 11 letters, and the repeating will be 4 I's. Okay, then we have 4 S. Then after that, we have 2 P, and we have 1 M. Okay, then from here, I will say that to arrange this, because the question doesn't mention just arrange how many letters, means that you have to arrange all of these letters. So to arrange all of the letters, number of arrangements is going to be using the factorial method, which is 11 factorial over 4i, therefore 4 factorial, then 4s, so multiply with 4 factorial for the s, and 2p, therefore 2 factorial. Okay, then from here, you will be getting 34650. So it is 34,650 arrangements. So that's all for the question number 1, first part. So now second part, the 2 letters are chosen as random from these 11 letters. Find the probability that these 2 letters are the same. Okay, which means now probability equals to probability of getting 2 I's, or is plus probability of getting 2s, or probability of getting 2p. Okay, so according to the previous listing here. So now I have 4s, I have 4i, 4s, 2p, and 1m. Okay, total 11 letters. So now since we are choosing 2 letters, that means it is the selection without replacement. Okay, so basically we have 2 methods to solve this question. The first one is you consider the selection without replacement, means that to get 2i, I have to choose 4 from 11 first for the first I. Okay, after that, once I have chosen the first I still have 3 more I left. So the total becomes 10 now. So therefore, the probability of choosing the second I, that is 3 over 10. Okay, plus, now to get the S, at first I have 4, therefore 4 out of 11. And after you have chosen 1 from the S, so here left 3. And the total left 10 now. Therefore, it will be 3 over 10, which is same as the previous calculation. And lastly, to get 2p. So at first, you only have 2p. Therefore, it will be 2 out of 11. But after you have chosen 1p, that means now here left 1p, and the total left 10 letters. Therefore, the probability of choosing the p is 1 over 10. Okay, so when you calculate this, this is going to be 26 over 110, and this can be simplified into 13 over 55. Now, this is the first way to do it. Okay, the second method is, alright, I will write probability is same as the selection because chosen, right? So, which means to get 2i, at first I have 4, so I'm going to use the combination method. So from 4, I choose 2. So since the selection is same as the selection without replacement, therefore we can use the combination method to solve this. Or to get the 2s, at first there are 4. So from 4, I choose 2. Or to get the 2p, at first I have 2p. Therefore, from 2, I choose 2. So over the total is 11, I choose 2. Okay, so this is the alternative method to solve this question. And at last, here is going to be 13 over 55. Okay, so that's all for this solution. 。 。 。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . Okay, question number 2. The following back-to-back stem and leaf diagram shows the reaction times in seconds in an experiment involving two groups of people, A and B. Now, given the key, 5/22/6 means 0.225 seconds for A. So we read in this way, and 0.226 seconds for B. Okay, so this is A, here is B. Now, first part, find the median and the interquartile range for group A. So basically, this is raw data. I would say that it is ungrouped data. So to find the median, I need to find out total number of data in the A first. So now my NA is going to be 4 plus 5 plus 8 plus 6 plus 3 plus 1. Okay, so the total here is 27. But since this is ungrouped data, my median, it will be half of n plus 1. This is the position of the data. This is going to be half of 27 plus 1 data. Then that is half of 28. That is going to be 14th. Data number 14. So data number 14, when you refer to this diagram, okay, standard leaf diagram, so this is data 1, 2, 3, 4, 5, 6, 7. You can just count from the total on the left side here. 4 plus 5 is 9, okay, and so on. Otherwise, you can just label. This is 8, 9, 10, 11, 12, 13, 14. That means this is going to be my median. So the value is 0.225. Okay, now for the interquartile range, we need to get the Q1 and Q3. So the Q1, okay, so now here, since the median is 14, therefore you can just use the division method, right? So here I have 14, that means I have 13 data in the first half. So I need to get the middle value of this first 13 data. So the middle value will be at 7 because it will be 6 to the left and another 6 to the right. Okay, so my Q1 is this value. This is my Q1, 0.215. So here I will write 0.215. And then my Q3 will be another half of the upper half. Okay, that means it will be from this part. Here will be 1, 2, 3, 4, 5, 6. So it will be 6 to the left and then another. It will be, okay, based on the previous calculation, it is a 7. It is a data number 7. Therefore, it will be data number 7 from the top. That means I will be getting 0. Okay, 1, 2, 3, 4, 5, 6, 7. Now let me check. Here 3, here 3. Right? So 225 median. Okay, 1, 2, 3. Okay, then here will be 1, 4. 1, 2, 3, 4. Okay, I calculated wrongly. The median, because I am considering the bottom, probably you can consider here. It will be 1, 2, 3, 4, 5, 6, 7. Right? So then another 6 here. 2, 4, 5, 6. So here will be 3 and here is 3, 6. Right? So that means it will be 2, 3, 6. So I will get 0.236. Therefore, my interquartile range, that is Q3 minus Q1, then it will be 0.236 minus 0.215. So that is going to be 0.021. Okay, that is the first part of question number 2. Now, the median value for group B is 0.235, lower quarter, this is Q1, is 0.217, and the upper quarter, which is Q3. Okay, now part 2, draw box and whisker plots for groups A and B on the grid. Okay, so now here, when you look at the median, all these values, okay, median 0.225, then the Q1 0.215236. So that means from here the lowest value is 215, 0.215, and then the greatest value is going to be 245. Okay, so and then I need to check the Q3, not greatest value, the Q3. Q1 is 0.215, and then the lowest value 0.20, and then the greatest 0.258. So which means I need to include my grid, or I will start my labeling from 0.2 up to 0.260 to include the lower and upper value. The least and greatest value. So here my labeling will be, okay, let me check here, 0.2, 21, 22, 23, 24, 25, 26. Okay, maybe I can adjust. So that means here 0.2, 200, 0.210, 0.220, 0.230, 0.240, 0.250, and 0.260. Okay, so just draw the line here first. So this will be the reaction time in seconds. So here I will write time seconds. Okay, so now for the A, the lowest value is 0.2. Okay, then the greatest value is 250. So 250. This is for the A. And then the median 225. So 225, that means this is in the middle. And then the Q1 is 215 from the previous calculation. So 215 is over here. Alright. Then the Q3 0.236. So this is 23, 236 is here. Okay, so just join. Right, so done for the A. And now for the B, the lowest value 205. So 205 is here. Okay, then the greatest value from the stem and leaf diagram, 258. So it will be 258. Then the median value 235. Lower quarter 217. 217, it will be here. Okay, after that, the upper quarter Q3 0.245. So 245. Okay, so that's all for the box plot or box and whisker plots for A and B. Right? So now for question number 3, check attempts the crossword puzzle in his daily newspaper every day. The probability that he will complete the puzzle on any given day is 0.75, independently of all other days. First part, find the probability that he will complete the puzzle at least 3 times over a period of 5 days. Okay, so now the x is the number of times that he will be completing the puzzle. So therefore this is discrete distribution, right? And it is binomial distributed because you are considering 5 days, and then out of 5 days there are at least 3 successes. So it will be x is number of days that he can complete the puzzle. So we are considering 5 days, therefore the n is 5, and the probability of completing the puzzle is 0.75 on a given day. Okay, now the probability is p x at least 3. So for your information, since it is binomial distributed, the probability is p x equals to x, which is ncx px qn minus x, whereby your x start from 0 then until n. Okay, so from here, at least 3 means that I will just say that this is from 3 to 5. Or you can say it is 1 minus 0 until 2, right? So I will just use this calculation to solve the problem. So now, when px goes to 3, that is basically 5c3. The p is 0.75. So from here, you should understand that the probability of success is 0.75. Then the probability of failures is 1 minus q, 1 minus p, which is 0.25. So our q is 0.25 here. And when px goes to 3 means that there will be 3 successes. Then I will have 2 failures. Okay, plus px equals to 4 means out of 5, 4 successes. And then the probability of success will be 0.75, and we multiply it for 4 times, then multiply with 0.25 degree 1, and plus with x equals to 5 means all successes. So probably I just write plus 0.75 to the power of 5. Okay, then from here, I will be getting the value 0.263672. This is a working, so I give more decimal places. So then the next value is 0.3955078, followed by the last value 0.237305. Then from here, when you get the total, this is going to be 0.8964848, and now you round up to 3 significant figures. That is going to be 0.896. So that's all for the first part. Okay, now can we also attempt the puzzle every day? The probability that he will complete the puzzle on Monday is 0.8. The probability that he will complete it on a Tuesday is 0.9 if he completed it on the previous day, and 0.6 if he did not complete it on the previous day. So when 0.9, that means he completed the puzzle on Monday, on the previous day. Otherwise, it will be 0.6 on Tuesday. Okay, so which means this can be shown using the tree diagram. So I'm going to draw the tree diagram right now. This is Monday. Okay. So complete or not complete. So complete the puzzle on Monday is 0.8. So it means not complete will be 0.2. So that the total probability is 1. And then now after that, for Tuesday, again can be complete or not complete, right? So from here, 0.9 on Tuesday when it is completed on the previous day. So here is 0.9 because previous day completed. If completed, now from here, C and not C, it will be total of 1. So I will get 0.1 here. I mean total of 1, yes. So then the 0.6 is when he did not complete on the previous day. But then he still complete on the on Tuesday. So that means here is 0.6. Then this is going to be 0.4. Alright, so this is the tree diagram. Now, second part, find the probability that Kenny will complete the puzzle on at least one of the 2 days, Monday and Tuesday, in a randomly chosen week. Okay, so for this question, basically we have 2 methods to solve. The first one is you can just direct count. So which means completes on Monday, okay, and Tuesday. Alright, at least one day. At least one day probably could be 1 or 2 days. So this is considered 2 days. Or probably only 1 day. 1 day means that completed on Monday, but did not he did not complete, he does not complete on Tuesday. Okay, this is considered 1 day. Or probably he did not complete on Monday, but then he complete on Tuesday. Okay, so here is considering at least 1 day. So which means when you consider the first one, that is basically both C and C. So you multiply 0.8 times 0.9 according to the tree diagram. All is plus. Completed on Monday, but not complete on Tuesday. So completed on Monday, not complete on Tuesday. That is the 0.8 times 0.1. Or Monday did not complete. So, and Tuesday complete. So it's 0.2 times 0.6. So this is going to be 0.72 plus 0.08 plus 0.12. Okay, then at last you will be getting the answer of 0.92. So this is direct calculation. Now another way is shorter. Okay, I would say at least 1 day. Now when you consider the number of days he can complete the puzzle, it could be no days, none of the days. It could be 1 day, it could be 2 days. But now the question asking for at least 1 day means that it could be 1 or 2. So I will say that I use the total properties 1 minus it is none, right? So this is our second method, which is total properties 1 minus P both not complete. Okay, this is a shortcut to solve this question. So 1 minus, if both days also cannot complete, that means that is the last case, which is 0.2 times 0.4. Then here you will be getting 1 minus 0.08, that is going to be 0.92. So you are getting same answer. So we have 2 ways to solve this problem. Okay, next question number 4. Now find the number of different ways that 5 boys and 6 girls can stand in a row if all the boys stand together and all the girls stand together. Okay, so which means now you have 5 boys, 6 girls. If stand together means that 5 boys in a group, 6 girls in a group. Or I would say that girls first, right? All the girls are on the left side and then all the boys are on the other side. So we have 2 choices here. That means now since these 5 boys are all different person, therefore number of arrangements this is standing arrangements, right? Can stand in a row. So it will be 5 factorial times 6g means 6 factorial, and there will be 2 types of arrangements here. Therefore you times 2. Okay, and now from here you will be getting 172800. So that is the number of standing arrangements. Okay, next part 2. Find the number of different ways that 5 boys and 6 girls can stand in a row if no boys stands next to another boy. Means that the boy cannot be together, right? Cannot be next to each other. So that means now I will arrange the girls first. So I will have girl 1, girl 2, girl 3, girl 4, girl 5, and girl 6. Alright, so then all my boys will be in any of these arrows, so that it will be, you will make sure that no boys are standing next to each other, right? So next to another boy. So that means from here my arrangements is number of arrangements. So since I have 6 girls, so I arrange first, it will be 6 factorial. And now here, right, look at the orange arrow. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 arrows, but I only have 5 boys. That means out of these 7, I need to choose 5. But then, since I have chosen 5, then I need to arrange because they are different person. Therefore, now here you have to use 7p5. Okay, you can use this way, or you can just write 6 factorial times 7c5, means that you choose the slots first, the arrows. After that, you times 5 factorial. So these two are same as 7p5. That's why I use 7p5 directly. Then that is going to be 181440. So this will be the solution of parts 2. Okay, question number 5. The Quivers Archery Club has 12 junior members and 20 senior members. For the junior members, the mean age is 15.5 years and standard deviation of the ages is 1.2 years. The ages of senior members are summarized by summation y squared, where y is the age of the senior member in years. Now, first part, find the mean age of all 32 members of the club. Okay, so I let, right, the junior be the x, right? Let x to represent the junior's age, junior member's age. So that means now here I will have nx is 20, then the mean age, so this is summation x, is 15.5, standard deviation as x is 1.2. Okay, so to get the mean, we know that it is total age over number of members. So now I need to find out what is my summation x. Oh, sorry, this is not summation x. This is the mean age, x bar. So I need to know what is my summation x. So now my x bar is basically summation x over n. Okay, so from here, my summation x is nx bar. Therefore, n is 20, x bar is 15.5. And here I will be getting 186. And you are given, right, the senior is y. Therefore, summation y is 910, and then summation y squared, that is 42850. So that means now the mean age for the total members, that is summation x plus summation y over nx plus ny. So my ny is 20 because it's mentioned here, 20. So here ny is 20. So this is going to be 186 plus 910 over 32. Right, because the total is 32 members. So then this is going to be 1096 over 32, and you will be getting 34.25, or probably I will just leave your answer in this form, 34 and 1/4. That is my mean age. Okay, now next part, find the standard deviation of the ages of all members. So then standard deviation, basically we need to know the summation x squared and summation y squared. Summation y squared is given, so summation x squared we have to get it from the standard deviation. So what I need to do is, firstly, I write down the formula for variance. then this is going to be summation x squared over n minus mean squared. Okay, so the standard deviation is given 1.2. So the variance will be square of 1.2. So I will write here 1.2 squared equals to summation x squared is unknown, but the n is 12. The mean is given in the previous part. The mean is 15.5. Oh, sorry, the nx is 20. Okay, the nx is 12. I wrote wrongly. This is 12. Okay. Then here is going to be 12. But there's no mistake in the summation x calculation. There is 186. Okay, I wrote wrongly. Right? So the nx is 12. The mean is 15.5. So here is 15.5 squared it. Okay, then from here I will get summation x squared over 12. So move this term to the left side. 1.2 squared plus 15.5 squared. Then after that, summation x squared is going to be 12 times these two, the sum of these two values. Okay, then you will be getting 2900.28. This is our summation x squared. Now, the standard deviation, okay, so standard deviation equals to square root of this formula. But then now, no more summation x squared. It will be summation x squared plus summation y squared over the n, the total n. Then minus the mean squared. Okay, so here probably I change to 32 because of 32 members. So then you will be getting square root of, okay, summation x squared is 2900.28 plus summation y squared. Summation y squared, that is given 42,850 over 32 minus the mean squared. The mean is this value, okay, 34 and 1/4. Then from here, you will be getting equals to square root of 256.63375, and at last it will be 16.0, correct to 3 significant figures. So this is your part 2 of the question. Question 6. A fair red spinner has 4 sides, labeled 1, 2, 3, 4. This is red spinner. A fair blue spinner has 3 sides, labeled 1, 2, 3. When a spinner is spun, the score is a number of the side on which it lands. The spinners are spun at the same time, alright, both spinners. So the X denotes the score on the red spinner minus the score on the blue spinner. Okay, so now draw up the probability distribution table for X. So I will draw the table first to write down the results after you minus. So let's say this is red spinner. So red spinner has 4 sides. Okay, then the blue spinner has 3 sides. Okay, so now it's mentioned that the X means the score on the red spinner minus, right, the blue spinner. That means now here if I minus 1 minus 1, 0, 1 minus 2, minus 1, 1 minus 3, minus 2, 2 minus 1 is 1, then 3 minus 1 is 2, then here is 3, 2 minus 2 is 0, then 3 minus 2, 1, 4 minus 2 is 2, 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. Okay, so the orange color means the x values. So from here, right, I will get my probability distribution table. Now, my x values, the smallest is minus 2, followed by minus 1, then 0, 1, 2, and 3. Okay, so now I just need to count. Minus 2, there's only once. So total here 4 times 3, 12. So NS is 12. Right? So means that now my probability is 1 over 12. For minus 1, there are 2. I see 2 times. So 2 over 12. When 0, I got 3 times. So 3 over 12. When 1, I have 3 times. When 2, I have 2 times. So 2 over 12. And for number 3, there is only 1 time. So 1 over 12. Now, this is a probability when the total the probabilities in the table here is 1. So you can just add up, it will be 1. That means this is our probability distribution table for X. Okay, so this is the solution. Okay, now next part, find variance X. So variance X, we need to calculate EX squared minus square of the expected value. So now firstly, I will count EX, which is the expected value. This is also the mean. It is defined as summation X times P. So which means you times the X with the P before you get the sum. So by referring to the previous table, what I need to do now here is I will just multiply and then I get the total up to the last term. So it will be minus 2 times 1 over 12 plus minus 1 times the bracket times a probability. Supposedly the next one is 0, so no need to write 0. So 1, then plus 2, the probability. And now when you refer to the table, the biggest value or the greatest value for the X is actually 3. So I will just write 3 plus 3 times the probability. So now I just need to copy the probabilities 2, 3, 2, 1. Okay, so 2, 3, 2, and 1. Alright, so when you calculate all these values, it will be 6 over 12. That is half. This is my mean. Now, I need to calculate EX squared. So EX squared is defined as summation X squared times P. So which means I need to square the X. Remember, the first value is always the X. So minus 2 squared with the same probability. Okay, this is 12, not 21. Then minus 1 squared times 2 over 12 plus 1 squared times 3 over 12 plus 2 squared times 2 over 12 plus 3 squared times 1 over 12. Okay, then from here, you will be getting 26 over 12. This is same as 13 over 6. 13 over 6. Now, at last, your variance X is basically EX squared minus square of the EX, which means this is 13 over 6 minus half squared. And this is going to be 23 over 12. Okay, make sure your variance is positive value. Now part 3, find the probability that X is equal to 1, given that X is non-zero, given that means conditional probability. So for information, conditional probability, we are going to use this formula. P A slash B, A given B equals to P A intersects B, over PB. Okay, that means now here I rewrite the question. This is going to be P x equals to 1 given that x is non-zero. So according to the formula, conditional probability formula, this is P x equals to 1 intersect with x is not equal to 0 over P x not equals to 0. Okay, so now when equals to 1 and intersect with not equals to 0, basically this is Px equals to 1. That is the intersection. As long as Px is not 0, though that means I will just use 1 minus Px equals to 0. This is easier to calculate. So then from here, you will say that Px equals to 1, go back to the table. That is going to be 3 over 12. So here, I will write 3 over 12 divided by 1 minus when Px equals to 0. So Px equals to 0 is again 3 over 12. So basically, I'm getting 3 over 12 over 9 over 12. Okay, so the 12 can be cancelled off. Both are denominators. Therefore, it is just 3 over 9. So when 3 over 9, this is going to be 1 over 3. So done for this question. Question number 7a. The time x hours for which students use a games machine in any given day has a normal distribution with mean 3.24 hours and standard deviation 0.96 hours. First part, on how many days of the year, which consists of 365 days a year, would you expect a randomly chosen student to use a game machine for less than 4 hours? Okay, so here will be all hours, and it's mentioned clearly normally distribution. So x is normally distributed with mean 3.24 and then the standard deviation 0.96. So we squared it to get the variance. And then from here, you need to count how many days. But before we count days, we have to count the probability first, right? Because the x is on a given day, right? So P x is less than 4 hours. So when x less than 4 hours and this is normally distributed, let's look at the formula. Px is normally distributed with mean mu variance sigma squared. When we need to count the probability, we need to standardize it to get the z or z. Okay, so it will be x minus mu over sigma. Alright, so from here, I need to standardize it. Therefore, it is 4 minus 3.24 because that is our mu. Then the sigma is just 0.96. And from here, you will be getting P, Z or Z less than 0.792. Okay, so now when you sketch a graph, this is a normal graph, which is bell-shaped, symmetrical at the origin, and the line here 0.972. That is on the right side. And because of less than, that means the region is towards left side. So obviously this region is same as the region on in your formula list. Therefore, you can just direct refer to the formula list and get the probability that is 0.7858. So you get this from table, right? And now the question asking for out of 365 days, how many days would you expect? So that means now remember this probability is only for 1 day. So the number of days, it will be 0.7858 times 365. Right? So this is going to be 286.817. So if I round up to 3 significant figures, that is going to be 287 days. So this is the solution for this part. Okay, now next part. Find the value of k for which this probability is 0.2. So now again the x is normally distributed. So we just standardize it. So when we standardize, k minus the mean. Mean is 3.24 over standard deviation is 0.96. Then this is 0.2. And now here I'm going to draw the graph. I'm going to sketch a graph. I need to find out where is this line. Okay, so now we have two choices. Either the orange color, which is k minus 3.24 over 0.96, or it could be the other color. It could be green color. Two choices, either on the left or on the right. Okay, but just for your information, if it is z more than 0, this is 0.5. Okay, now here more than means from the line onwards, and the probability is only 0.2. That means obviously here is 0.2. Okay, if you take the green color, that means it's greater than 0.5. So which means now I'm sure that my line is on the right side. Okay, so then from here, since this is on the right side, so I know that the k over 3.24 over 0.96, it will be a positive value. So as long as positive value, no need to do any reflection, just keep it as it is. Then what to do is the probability before that, it will be 0.8. Right, so from here I will write p z less than k minus 3.24 over 0.96, that is 0.8. Okay, so now when you read the table, so from table you read the body of the table 0.8, and you get the z value or z value from the first column and also the first row in your table. So from table, pz less than 0.842, that is 0.8. Okay, so now I will equate these two values to get the k. So which means now I will get k minus 3.24 over 0.96, which is 0.842. Okay, so from here, to get the k, the 0.96 will be moved up, and later on this minus 3.24 will be moved to the other side as well. So here I will write 0.842 times 0.96 plus 3.24. Okay, then now here you will be getting 4.04832, and at last when you round up to three significant figures, that is 4.05. Okay, now part 3. Find the probability that the number of hours for which a randomly chosen student uses a game machine in a day is within 1.5 standard deviations of the mean. Okay, this means, let's say this is the x. It will be 1.5, sorry, this is not the x, because it's mentioned 1.5 standard deviation of the mean. That means this is the mu. And here is 1.5 standard deviation. And then the other side is also 1.5 standard deviation. Okay, so these two boundaries, it will be mu minus 1.5 sigma, and the upper boundary will be mu plus 1.5 sigma. So this is the meaning of this last sentence. So now you need to count probability. So P and X between these two values. So X between mu minus 1.5 sigma and mu plus 1.5 sigma. Okay, then from here, again, when we standardize, refer to the normal distribution. We always use the x minus the mu over sigma. Alright, so now here I will not write down anything first. I will not replace the mu and sigma, but I will just use this general form. That means it will be, this will be the x value, then I minus mu, okay, over sigma. So the middle value change to z or z. So mu plus 1.5 sigma, then minus mu, because this is your x, then over sigma. And now from here, I will be getting, okay, when you look at this, minus mu, sorry, not minus 1.5, minus mu. Right, so from here, the mu will be cancelled off. Then I will be getting p minus 1.5. And then this is, again, I get positive 1.5. Because the sigma will be cancelled off. See here, mu minus mu, then the sigma over sigma. Alright, so basically, you are counting the probability of z or z less in between minus 1.5 and 1.5. So now I will sketch a graph. Here is negative 1.5 and the other side 1.5. So since it is in between, that means this is the region, but then I know that it is symmetrical. So when it is symmetrical at the origin, which means the total region is actually double of this green region. The purpose I flip it to the right side, which is a green region, is because of I don't want the negative. The negative is not available in the table for the normal table. So that means now here I will be getting, this is double of the z between 0.0 and 1.5. Okay, so now to get this green color, green region, it will be the probability of z less than 1.5 minus probability of z less than 0. So here 2 p less than 1.5 minus p z or z less than 0. Then from here, just read the probability from the table. You will be getting 0.9332. Then minus less than 0 means 0.5. Then at last, you will be getting 0.8664. And now you can round up. This is 0.866. So which is the answer correct to 3 significant figures. Okay, next part B. The variable y is normally distributed with mean mu, standard deviation, sigma, where 4 sigma is 3 mu, and mu is not equal to 0. Find the probability that a randomly chosen value of y is positive. Okay, so now it's mentioned y is normally distributed with mean mu, variance, as standard deviation sigma. So if it is variance, it will be sigma squared. Now 4 sigma is 3 mu. Okay, then from here I will get my sigma as a subject. So my sigma is basically 3 over 4 mu. So now I will replace this by y is normally distributed, mean mu, variance is 3 over 4 mu squared. Okay, after you get this, what to do is you need to count the probability that y is positive. So it means y is greater than 0. So again, it is normally distributed. So I will use standardization. So it will be 0 greater than 0 minus mu over sigma. The sigma is 3 over 4 mu. So obviously from here, the mu can be cancelled off, right? Because the numerator just left mu. That means you will be getting negative 1 over 3 over 4. So this could be simplified into greater than negative 4 over 3. So when 4 over 3, that is p z or z greater than negative 1.333. Okay, so now I sketch a graph. negative 1.333. Okay, but since it is greater than, means towards the right side. This is a region that you need to calculate. Then now, since the region, the value is negative, therefore I flip the region. Right, so when I flip the region, or I flip this blue line, it will be positive 1.333. So the region now becomes the region towards left side. So which means this is basically same as P Z less than 1.333. And since the region is on the left side, then I can just use the table, get the value directly. So this is going to be 0.9087, and I round up to 3 significant figures, that is 0.909. Okay, this is the solution for this part B. Okay, so we have come to the end of the video. Alright, so thank you for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. Alright, and also stay tuned for more upcoming videos. Thank you. Bye.